Um, so first of all, I'm going to ask how did the graphing go, like the textbook questions? We were okay with that? Um, I did post the answer key, right? It showed up at 5 or so. Okay. And that was my version of doing those questions. I think that those questions are way too plain, like they should have done the A, B, C, D. But that's why I asked you to graph it, because really, if you have to graph it, you have to think of all those different components, right? And things aren't just X and Y anymore. Things are, time and height, distance and height, and so forth, right? Time is a big reoccurring variable, okay? So we're going to do a second example here together. And we'll solve that. This is equation, by the way, EQN, when I run out of room. Actually, I'm going to give you I'm going to stay there for a bit because I know that at home when you're on your phone, it's harder to write this down. So I'm trying to learn to wait for you. It's not the same as being in class. A, determine the maximum height of the arc. Yeah, you know what? If you want to sit here, that's fine too. Yeah, I'd be fine with that. I try to keep students away, but this is a bigger group, so I'd be fine. You know what? Is that better? Yeah. But you can still move if you want. So on a test, it's most likely that I will only ask you like A, B, maybe C. So you won't have as many as here, but you should be able to answer any one of them, right? So don't always get too used to me like setting it up and this is A, B, C, D, where you literally find everything. So by the time you're graphing it, you have everything already. I might jump straight to the graph. If I ever do that, you need to know, right? Okay, I gotta find my vertex. I gotta find the intercepts. Being very careful that this is now a word problem and my graph will not look like the one I showed you on the AC. It will be probably restricted to quadrant 1, okay? And so we'll look at that, okay? Okay, so first things, we're gonna type in our equation, right, into the calculator. So go ahead and do that. How are your battery levels, folks? Are they still green? Yeah? Yeah. Okay. For some reason, mine was dropping significantly, but that's maybe because I was using it, having the screen on all the time, trying to prepare. So we're going to type that in. And notice that I give you 3 decimals, right? You enter it exactly the way it is. Don't round it to 2 decimals. If I give you 4 or 5, you enter it that way, or else your answers will vary, okay? So once you've entered it, what I want you to do in your, just by looking at it in your mind, right? You're looking at this and you're thinking already, okay, this parabola is going to be pointing downward. This parabola is going to be a wide parabola because it's 0.1 something, right? So it's going to probably span quite a bit sideways. Another thing is very important. Watch the equation here. Do you notice that there is no constant term there? So your initial height is going to be what? 0. You're starting off the ground. If there's nothing here, you are literally starting, action is starting right off the ground. And so it's a 0, 0 scenario. That's where you start, okay? So A, it says, what I'm going to do first of all here, I'm going to start answering. So what I will just tell you is that in grade 12, as well as here, we know that whatever is on this side is x, and whatever's on this side is your y. So really, every point on this graph is going to be distance and height. Okay, so if you find a point, right, you know that the first number corresponds to distance, the second number corresponds to height, okay? So that's just to start off, right? And we're going to say up, wide. This is just for us. Sorry. Sorry guys, it's been a long day. Down, down and wide. Ay, ay, ay. I told you that's not going to be the last time, right? All right, down and wide. Okay, so let's enter and try to graph it. That's the first thing you want to do, right? Like, can I even see this on my calculator? And I hit the graph button. There we go, the contrast, there. That's better. Okay, so right away you see that it's a wide one, so it's going to span. If you're not seeing this because you were doing homework yesterday, zoom 6 gets you back to the beginning. And so now I'm just going to expand my window. So I'm going to go sideways. I'm going to expand X max to, let's say, 50, and Y max to, let's say, 50 as well. Like, I don't play around too long to get it. Like this, I would stop right there. I wouldn't try to make it look prettier, right? You can if you want. As soon as you see the whole thing, and we are in quadrant 1, which is where we want to be, we're good, okay? So let's answer A, which is determine the maximum height of the arc. So obviously we're looking for the vertex. So we're going to answer A. And before we do anything, we will do second trace. And in this case, we have a max. Okay. So we go ahead, and if you choose min, it's going to be wrong. Okay. So max, I'm going to go to the left of the vertex, hit enter. I'm going to go over to the right, hit enter, and it's 12. This will definitely round to 12, 18. Right? 12, 18. There's no e's or anything, so we don't have to worry about zeros. So we write down 12, 18. So you write down you give me the keystrokes, you write down the point you found, and then you will say 18 feet is the maximum height. That's it. Or the maximum height is 18 feet. It's up to you really, as long as you don't leave it like this. If you leave it at 12, 18, you won't get full marks. Okay. B. Determine the maximum horizontal distance. So what are we talking about here? The maximum horizontal, like this is a horizontal distance, right? So we're looking for what we used to call the x-intercept, right? So this is the x-intercept that we're after. So we're going to go y2 is equal to 0, and then we're going to find the intersection. And I'm going to get my bracket ready. So y2 is equal to 0, hit graph, second trace 5. Enter, 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 24, 0. Okay. If this had been, right, something 1 point something something e to the, you know it's 0. Okay, don't write something. It's very clear that it should be 0. Maximum horizontal distance is 24 feet. Watch for the units. If it's in meters, right, then you write down meters. So there it is. C. Calculate the height of the stream at 0.5 feet from the opening. Okay, so basically what are they giving you there? Calculate the height when the distance is 0.5 feet. So they're basically saying if the distance is 0.5, what is the height going to be? right? Because this is my distance and this is my height. But we also know that this is x and y for the calculator. Okay. So what do we do here? What function do we want to call? Yes. Second trace one? Okay, right on. So we're going to say second trace 1, x is going to be equal to 0.5. And then we're going to get our y value from that. So let's go ahead and do that. Second trace 1, put in 0.5, and y is 1.47. Okay, 1.47. And you can put down feet. And if you circle that and tell me that that's the answer, you have your units there, everything is there, you have your keystrokes, that is as good as, that's all I need. Okay. If you have a different teacher next year and the teacher says, no, I want like a full sentence, you give that teacher a full sentence, all right? But I don't need that, okay? I clearly, I would understand that you know what you're doing there. Like this is what the answer is to my problem here. D, I switched it around on my original a little bit, so, but D, based on what I give you, is calculate the distance when the stream reaches a height of 1.5 feet above ground. This is different. They're asking you for the distance if the height is 1.5 feet. Again, this is distance, this is height, this is x, this is y, right? So point on the graph, what does it mean to us? What does the calculator need to get, right? So in this case, when you are given a y value, you make y2 equal to it and graph a horizontal line that will indicate this is the y value in question. And you're going to go second trace 5. And let's go ahead and do that. So let's plug in 1.5 for our y2 and hit graph. And it's not as zoomed in as I would like it to be, but you can tell that it happens twice. It happens once on its way up, and it happens again on its way down, right? So when that happens, you have to mention both of them, okay? Okay, so there are two instances this stream reaches that height on its way up and on its way down. Okay, so we're gonna say, let's find the first one. So second trace 5. I'm gonna actually find the first one. It doesn't matter to me which one you find first. So enter, enter, enter. Before I continue, I'm just gonna say something because I want you to remember this. If this red line would have made contact with the curve somewhere in the negatives here, you would have omitted it. You would not have included that, right? Because, right, like distance, in this case, it's all like going to the right. Time can't be negative. So in this case, I can tell that it's positive, right? The x value, the distance is positive. So 0.51 and 1.5. So I write that down. 0.51, 1.5. And we're going to find the other one, which is also going to be at a height of 1.5. I know that already. So second trace 5. travel all the way over. Once you're over the hump, then you're good. 2349, round it. 2349. So I will just make a note. Reaches 1.5 feet twice. First time on its way up. Second time on its way down. So you need to make sure you account for that if you see that, right? So you would say stream, this would be my answer, is either 0.51 feet or 23.49 feet from the opening. So there the wording does matter, so you want to say that. All right, E. E is different. It's worded different, and that's because that wording is often used in grade 12 applied. And students kind of get stuck on that. It's like state the restrictions on the domain range. Well, if you're saying that the domain is only valid from here to here, right, and here to here, like up and down, you are restricting the domain and restricting the range. Okay, that's all it's saying. You're trying to find the values where it starts and ends, starts and ends. Okay, so don't let that throw you off. So the domain in this case, I'll give you both notations, right? The one that I prefer, first of all, your domain starts at 0, right? The distance of 0, and it goes all the way to where it hits the ground, right? So what would that be, that value? In B, we reach the maximum horizontal distance of 24 feet. That's like your x-intercept. So in this case, you would actually have to put 24 down here. So x values go from 0 to 24. If you wanted the set notation, you'd have to use d as the variable. And for my range, I would like, you are touching the ground at some point, so you go from 0 to the highest point, which is found in A. What did we find in A? It was 18 feet. Or 0 H 18. This is maximum height. And this here is maximum distance in this case. If it had been a time problem, it would be the time at which the ball hits the ground or where the action ends, okay? And now the best part of all is graphing, okay? A graphing question in grade 12 applied exam on the provincial exam is 3 to 4 marks. If you know how to graph, like 3 to 4 marks is a lot on a provincial exam. If you know how to graph, and there's sometimes 2 questions that graph, right? You have 6 marks in your pocket, and it's usually just, here's the equation, graph it, right? Here's the equation, can you graph it? And so that's why I emphasize that quite a bit. So I'm going to graph it here. That's F for us. I'm just going to make a note. The vertex is, where do I have it? 12, 18. The x-intercept, I actually have 2, by the way. I have 0, 0, and 24, 0. Y-intercept is 0, 0 as well. Maybe what I will do here is just rewrite it one more time. Whenever you see the constant term missing, you know that this action starts on the ground. And if you're not sure, it doesn't take long to double check, right? Like if you're looking at your calculator and you're like, wait a minute, what was the other x-intercept again? Let's change that to 0. Right? I'm gonna try to find this starting point here. So second trace 5. I want the beginning, right? Enter, enter, enter. So it is 0, 0 there, right? You find that it's 0, 0. Okay. So it's not. This is just to. I think it's always nice to have 2 ways of checking, right? I'm going to use my calculator, and this confirms it. Okay. All right. Let's graph. I know that I'm bound to the first quadrant. So don't be shy, like don't make a tiny graph that's hard to read, right? Like just use up a couple lines, okay? I'm gonna say this is distance in feet. Do that first. That way you're not gonna lose marks there. I'm gonna need, for my x here, you want to decide like how far do I need to account for, and my x-intercept, the one that's furthest out, is 24. So if I go up to like 30 or 25 or something like that, you're good to go. So what I'm thinking is going up by 5. So 5, 10, 15, 20, 25, right? If I get there, then I'm good. Now I will make sure 24 fits on there, right? In terms of the highest point I'm going to reach, you get it from the vertex, right? And that's 18 feet. So if you go up to 20, you're good. Since I have a lot of room, I'm going to go 1, 2, 3, 4, make that 10. 1, 2, 3, 4, make that 20. Okay? Because I have a lot of room, I'm going to give myself, but notice that I'm using the lines and it's consistent, right? So to make it easier on me, I'm going to go 5 halfway and 15 between 20 and 10. And so now it's a little bit easier. Use a different color for the points that are important. I know that this is 0, 0. I know that this is 24, 0. I'm at 12, 18. So there you have your 3 points. Remember that. To get a parabola on the calculator, you need 3 points minimum, because we're going to go backwards later. I'm going to give you 3 points, and we're going to get the calculator to come up with the equation. It's called the regression. Okay, so it's up to you if you want to start here. Maybe it's better like just curve away and then down. Right? Go away and then down. No arrowheads. Nothing like crossing the x-axis, because then you're violating your domain and range. If you're going cross it, then your domain and range is now off, because you told us that we're bound to this. Okay? We're gonna make sure we have our equation on there, and we're gonna label those points. And that's your graph. If you're at home, okay, I want you to look up these 2 handouts that I'm about to show you here. Yes, will there be a similarity between the ones you've done yesterday and these ones? Maybe a little. So look up these 2 handouts. This is the first one, and then there's the 2.0. So look up these 2 handouts that I've made to practice.